I should have put this on the last one, but I didn't. Slide up, would you? There we go. Wanted to show you something. Now, in these squares, we used absolute references. A2 and B2. A2 and B2, and then we did A4 and B4 over in this column. And it did the calculations. We added it up and we graphed it. And here's what it looks like in LT Spice based on the circuit we did. And I had come up with the values for the amplitudes based on just doing some circuit analysis in my head, and you can see I'm a little off. This goes to 10, this doesn't quite get to 8, so I need to tweak these a little bit. The nice thing about using the values that we used as absolute references is I have a point where I can change one thing. Let me show you what I mean. If I go in here and I change this to a 6 and I hit the enter, watch the graph. Did you see that it came down a little bit? Well, let's make a bigger change. Let's change it to a 4. And you see now that it redid the axis and I'm way down. And I started out with a 7. I think 6 is probably where it needs to be. You can tell me I need to be somewhere around 8 volts for this peak and almost 9 for that one. It's still a little bit high. So let's see what we can do here. Maybe 5.8. 5.7. Let's do that. So now I'm not quite to 10. And I'm almost to 10 here, which is what I've got. And about 7.5. 7. Yeah, 7. So you can see you can go in and tweak things. If you want to see what it looks like on a 200 hertz waveform, you can change the frequency. And now you can see what a 200 hertz frequency mixed with a 350 hertz frequency looks like. You can't really go higher than the highest frequency we did because we took that highest frequency and did our sampling time. So if we let's set this back to 100. I get my waveform back. Let's say I went 3500. Then yes, you see something, but it's not great. And if I did 35,000, then I wouldn't really see the very high frequency pulses on my waveform. So you'd have to go back in and recalculate. So, but I can go back to what I was. And I can change this to 3.9. Shouldn't make that big a difference, maybe a little bit. And that's why we took the extra step of the absolute references, the absolute cell references. Because anytime in Excel, if you're doing a lot of formulas like we were doing and adding them up, you want to go back and change something. Instead of changing all these equations, you can just change one point and all your equations change, all your values change. And that's one of the things that really makes Excel a very powerful tool that a lot of people like to use. Anyway, I thought of this after I did the last video and I wanted to mention it. But once you get to this point, this is when Excel's fun, because you can go in and make changes and see the effect. You could actually do it in the lab. You could actually say, okay, I want to do a 350 and a 150. And you could say, okay, what happens? What would that waveform look like? And then you could bench it up, change your frequency, and you'd see that your waveform would change. And then you've got a tool here to predict exactly what your waveform would look like. Anyway, I just thought I would share that with you, and thank you for watching.